Okay, we're going to now transition to our Lightning Talks round. And our first presenter is Dawn Frood from Florida Atlantic University. I hope I pronounced your name properly. Sorry if I did not. And Dawn is going to be talking about AI for all, transforming a library space from concept to reality. So Dawn, I will turn it over to you. And we can see your screen, but you're muted.
All right. Hi, everybody. So I work at FAU. I'm in the collection management department, and why I'm here today, I'm not a specialist in anything to do with AI, although I've always had an interest in computers. And when I was just kind of to tie things to some of the information that other people had mentioned is libraries have always been in the forefront of kind of emerging technologies. And when I was young, when I was in middle school in the early 80s, girls couldn't take computer classes at our middle school. The boys would take computers, the girls took typing, and I kind of found that a little bit unfair. And after school, I was fortunate that I was able to sign up for some classes using computers. And in order to get practice with that, I would go to the elementary school and teach the elementary kids how to, with my big floppy disk in hand, teach them how to do some coding. So I've kind of been using libraries as a way to, like, a gateway into technology for quite some time now. So I was thrilled when our university had decided that they really wanted to get on the bandwagon with AI. And I really do feel like it's an equalizer as well. So let me get my kind of. So the collection management department encompasses now what used to be our technical services department. And what had happened right before I had started at FAU, we had some advisors come in and recommend that we take the 25 staff that were in technical services and move them into other areas of the library because we had some deficits and some needs that weren't being met, and they felt that that would be a method for doing this. And so the library dean took their recommendation and relocated most of the technical services staff into other areas in the library, and collection management ended up absorbing three of the people that did the technical services functions, and they came into our area. And we actually, for a short time, so I started in 2018, but for a short time, we actually had all of that empty space was ours, as well as our office space. So it's a wonderful location in the library. It's a prime real estate where these palm trees are in the picture, and there's some other little trees behind there. It's all that whole first floor at that end of the building, and it's a large concept space. Originally, it had 9 offices, and then also a conference room, and we took 3 of those offices into our space, and the other 6 became a part of what is now our artificial intelligence lab. So really, Dean Hickson, she's our former dean. She's no longer with the libraries. She was really instrumental in getting this getting them into our space. She'd already done quite a bit in our university to reimagine areas and make them more user-friendly, more open for the students, and more engaging. And it had started up, we're a 5-floor library, and it started off with the 5th floor that used to be it was previously closed off to the public. She opened it up. She put it's an open concept space, put movable furniture in there so students could create whatever kind of learning environment they wanted. It's such a beautiful and versatile space that the university often comes in and uses that space. In the library, we use it for training in different activities. But coming off of something where she's already taken a space, she's also we had some office spaces that were in pretty prime location as well, and she converted them to more study rooms for the students. So she was already thinking along those lines. And so when we disband, and I say that in a positive way because I think it ended up to be a great thing. The technical services department, she was looking at different ways that this space could be used. And originally she had thought that maybe we could bring a gaming lab into that space where students come in and game. And also she was considering ideas of maybe generating revenue for the library. Places like WeWork or some other organizations where they will rent out office space. And since it was on the first floor and really prime, we thought maybe we could get some money out of that. So that was another kind of something that she had looked into. But she'd let administration know that this is something that she's looking at. We have this space, and kind of had primed everybody to know that we had something special available. And at the same time that she was doing this, in the College of Science, there was a machine perception and cognitive robotics laboratory that had been set up, and it was a very special space. The two professors in the picture on the left had a goal was really to bring the AI and robotics to the masses in a way that's very cost effective. And they use a lot of, I interviewed William Hahn, he's the man on the right-hand side bent over, for this presentation. And when I spoke with him about this, he said that they didn't have a budget. They had a very small room, and they bootstrapped their lab. They were able to go to our surplus department and get computer parts, and they had worked with some people from the community to get the kind of like computer chips that they would need. And NVIDIA was a company that worked with them to give them some graphic cards that typically you use in gaming and modern AI. And so they really did a lot for free, in essence. And what had happened is, when this lab kind of got going around the same time, a man named Herbert Gruber had retired and moved to Florida, and had been spending time around the university in just kind of wandering as a citizen of our town. And he went to the like our PR department at the university and told him who he was, and asked if they could help him get engaged with some of the students on campus. And so because he's somebody who is he was a visionary entrepreneur that worked in telecom for many years, and they sent him over to this lab, and he got to walk around and see what was going on, and he started to get really involved. He was very impressed with it because they had in this lab, they had undergraduate, graduate, postgrads, high school students, all different people interacting, doing research together, and all in this very tiny space. And there was a point where he had said he had never seen anything like that. And there was a point where he started funding workshops and just got really involved in mentoring students. And then he realized, no, this needs to be something bigger. And he reached out to the president of the university at the time. His name is John Kelly. And he came together with them, and he brought President Kelly into that space, and he had never been in that space before. So I think that was kind of a neat thing. And President Kelly said in the 3 years that he had been at the university, this was the best thing he had seen so far. And I believe I wasn't there in the room with him, but I believe that he had already been primed with the Ruben Gruber stressed that they really need more space, more resources need to be dedicated to this. And the president was aware that the library had this space. And I think he kind of connected the dots and ended up bringing Ruben and William and Elon into the library space and showed them what we had. And I think this was kind of the beginning of our project. When I interviewed Dr. Hahn for this, he said that they were really thrilled that to get involved with the library from the onset. He said that he felt like libraries are a natural place to bring AI and AI to the masses, and he was comparing it to early 90s and the inception of the internet. And we didn't just have internet everywhere in the early 90s. It was something where if you lived on campus and you lived in the dorms, you couldn't do your homework in the dorm. You had to go to the library to get access to just the internet. And he felt like this is where we are with AI. People need to be able to it's not everywhere. I mean, it's I guess it kind of is everywhere, but they have the resources, they have the computing ability to really do great research with AI. So it's kind of at a whole nother level there. When I interviewed Dr. Hahn for this presentation, I said, you were very fortunate. You almost had like a unicorn serendipitous moment when Ruben Gruber walked in. How do you think other libraries could do this and replicate this? And he really felt like the fact that they had an open door policy and that they allowed everybody in, like they didn't try to make it this special College of Science thing. They opened it to everyone, and they were giving tours of the facility. And he felt like really getting more eyes in that space was very important to the process. So, but as a result of Ruben Gruber speaking with President Kelly, the university received a $1 million what did you call it? Gift. And the gift wasn't exclusively for our labs, but we did. It was kind of shared between student scholarships and that type of thing. But I'll give you the breakdowns in a moment on that. So the group. Ruben, Gruber, we kind of call him Gruber, he had this concept that he really wanted this to be considered a sandbox, a place that was collaborative, experimental, and really bringing everybody together in this space. And when we were designing as a library, we were kind of getting in the conceptual stages of this. We had decided that we wanted to model it off of what we had done on the 5th floor with the modular, very open concept. You could take the space and do a lot with it. Now, in the rendering you see on the right there, you can see that's more fixed furniture. And we really, that was just what the architects put together. But it does look a lot like that. It's just everything is more mobile. We even have thought this they thought this through so carefully that on the ground there are outlets all over the whole, like little spots all over the place where you can plug in, because they want to be prepared to have this access to all of the resources anywhere at any time. So shoot a little bit to the next one. So with the funding, the libraries have put together total for this project just over $280,000. Initially, we put in 120, and we got some money from the university overall, and then the Gruber donation gave us 290,000. So at this point, the library is almost matched what the Grubers have given us, and so this wasn't a cheap endeavor. So it's kind of funny because I think of William when he first started this with bootstrapped and wanted it, to do things so cheaply, and it's become much more than that at this point. But we also have much more potential. So it's been a wonderful project. So one of the things that if you're looking to do something like this in your library, you want to think about very early on is putting together a memorandum of understanding for whoever your partners are and whoever you perceive your partners to be in this process. And when we first put together our memorandum of understanding, it was with the College of Science. So the dean of the library and the dean of the College of Science got together, and they looked at their goals and what the missions were, and they wanted to really find ways to elevate the university in with this space. So, but the memorandum of understanding is very integral to this whole process. And in that form, we talk about expectations of what the library is going to provide, the university is going to provide, College of Science, and the other thing that I think is really important in doing this, these aren't the glamorous parts of putting the lab together, but they're very important, is we did establish a library advisory committee that meets regularly, and they recommend priorities. It encompasses people from the university, college, administration, members of the community, and they really propose a lot of the different activities that they expect to see happening in that space. So once we did get that space, the library brought in our own kind of specialist to our team. And Mahesh is somebody who's really been important to kind of get me up to speed in speaking here today as well. He came in with interest in artificial intelligence, and we pulled in arts and letters. So now it's science, the university libraries, and arts and letters. And we brought somebody who would work with NASA and has been on the History Channel and is very distinguished. And am I out of time? No.
Yes.
Oh my
Yes.
God, I'm so sorry. Oh, so, all right. So I will share my PowerPoint with you. There was so much going on with our program.
Yes, please. We would love to see the
Okay.
your slides. And I'm sorry, 15 minutes goes quickly.
I didn't really, yeah.
So thank you, Dawn. We appreciate it. So these are really quick lightning talks. So we've got a quick turnaround. So I want to go ahead and hand it over to Allison Faix and Samantha Duncan from Coastal Carolina University. And their talk is using Research Assistant AI for finding scholarly articles.
Great. Okay, just one moment, everyone. We get things set up. Fantastic. Allison, do you want to take it away? Oh, you're muted.
You're unmuted now, Allison. Let's see, but I don't think we can hear you yet. Still can't hear you.
Nope. Allison, I wonder if you should try using the mic on your computer instead of your headset. I don't know.
One will work better.
Oh, there, we just heard you.
I can hear you.
Okay, thank you. I'm so sorry. We want to thank everyone for coming to our lightning talk using Research Assistant AI for finding scholarly articles. My name is Allison Fay. I am the instruction coordinator at Coastal Carolina University.
And my name is Samantha Duncan, the instructional design librarian at Coastal Carolina University.
So we wanted to do a really quick outline of our session. We are going to define some terms that we think are really important, talk a little bit about why we're doing this. We have two research assistant AIs that we're going to talk about and demo. We'll talk a little bit about the pros and cons of using these. We'll do our demo and talk a little bit about things that we see coming in the future. And you can see on our outline, this moves so fast that when we originally planned this, we actually had a different one that we were going to demo for you. And we found out a couple weeks ago that it's not free anymore. So we decided to switch to a different one.
All right, so when Allison and I were discussing this presentation, we thought it was really important to define or make a distinction between artificial intelligence and generative artificial intelligence, because we're already using artificial intelligence in our consumer products or education or everyday lives. We've been using it for quite a while, right? Navigation applications, smart home devices, education, Grammarly, Microsoft Editor, our email spam filters have variants of AI. And so it's only since as of November 2022, when generative artificial intelligence, these large language models, these chatbots became more widely available to the public, did things start to catch fire. So artificial intelligence learns how to learn, then it is able to generalize what it has learned and apply that knowledge. Generative artificial intelligence recognizes patterns and can generate new content that mimics the data it was trained on.
Okay, so why are we presenting about this? I think like everyone else, when ChatGPT went viral, as librarians, we started to get lots of questions from our students and from faculty about this, a lot of requests to track down sources, which we couldn't track down. And then faculty started asking us if we would teach students why they shouldn't use ChatGPT to do research. I think that like that just wasn't the angle we wanted to take on this. We wanted to investigate, like, you know, like we also were not impressed with ChatGPT's ability to find research, but like artificial intelligence seems like it does have potential to help researchers. We wanted to look into what ways could it actually help them and explore some of the benefits and the challenges of this. So one of the ones that we're going to demo for you really quickly is called Consensus. And this is a research assistant AI that was created to search for claims in scholarly literature and help researchers like really quickly get a look at what the literature says about their research questions. It is pulling sources from Semantic Scholar, which is an earlier tool, and you put in your research question and it pulls the top papers, and it shares like a consensus meter and a short generative summary of what the research says in answer to your question. And you can create an account at consensus.app/search.
And so the second research assistant that we're going to demo is Research Rabbit, which is a literature mapping tool with a pretty innovative user interface design, and that it has interactive visualizations. When you begin adding papers, you begin to discover other networks, and Research Rabbit learns from your collections and improves upon its recommendations. It searches PubMed and Semantic Scholar, and you'll see Research Rabbit that has columns that represent some search or browse action, such as looking at all the references of one paper or looking at publications of a certain author, avoiding that constant switching between different modes of searching and browsing, which is one challenge of doing literature reviews.
And so before we do our really quick demos, we wanted to talk a little bit about the pros and cons that we see as we start to use these with faculty and students. We like the ability to have interactive visualizations in some of these, the way that they can synthesize your search results with like custom summaries seems like it could be really valuable. Quickly being able to identify methodologies is valuable too, and just helping to see the connections between articles and discovering new networks. Some of the things that we haven't liked is just that the links out to the full text are not always included. So we don't really like when our students get directed to pages that ask them to pay money for articles, and there's no way that we can intervene other than teaching them not to pay money for articles. There are like a learning curve for a lot of these. We have searched high and low, and we still haven't found one that really specializes in the humanities. So if you know of one, we would love to hear about it. It bothers us that you have to create accounts to use these. There might be reasons why students might not want to do that. And as we have found out, it is super fast changing and these do not stay free. So you really have to keep up with what is available.
And so now I'm just going to stop sharing my screen, and then Allison is going to pull up a consensus. So go ahead, Allison.
Okay. Thanks. Yeah, and I'll just share this really quickly. So this is consensus, and you can see like the search interface is really simple. There's just a box here. But they do a lot of explanation of how to search. It really wants you to ask questions, and it gives examples of the type of questions that you can ask. So Sam and I have been asking the same question as we demo these. So we're gonna ask, let's see, learning styles affects college students. And we'll click search, and they do have some information on here about how this works. But it's going out and finding like what it thinks are the top articles to answer this question. It usually should tell us, like I found 14 this time. It's analyzing the top 10 up here. And so it does give you this little summary. That is the generative part of this. I do like how they have this little warning that tells you like, hey, we're only looking at 10 papers at a time. And like, this is, you know, not necessarily going to be correct. It is also like one of their features that you might have to upgrade to keep using. So far, I haven't used up any credits, so I'm not sure about that. But it does tell you that like 57% of these papers answered yes. 29% said maybe, and then 14% said no. I will tell you, like, if you ask the same question in a slightly different way, you get different numbers, which is not great, but good to know, important for students to know. And then as you scroll through these, I do like how it will pull out what type of study it is, and you can see like the sample size really easily. I think that's really helpful when students are just first learning like why these things might matter as they go through. And if you click on the article that you find, this is where you do get some links out to the full text and then to the Semantic Scholar record here. So, and there's a lot of like other little things you can do, but we want to keep this really quick. So I'm going to go ahead and stop sharing so that Sam can share Research Rabbit.
Great. Thanks, Allison. And so for the sake of time, I've already created, so this is Research Rabbit. This is the interface that you come into when you log in. I've already created a new collection for the sake of time, learning styles and college students. So you do have to create a collection first before you start adding papers. So I'm going to click on the collection. Now I can click add papers. And so you can either add papers by the title of a paper, DOI, or keywords. I'm going to stick with keywords, and I'm going to use learning styles and college students. And I will click search. So again, searching PubMed or Semantic Scholar. And so now Research Rabbit has come back with some recommendations for me. So I'm just going to scroll through these recommendations, and I'm just going to click to add some of them to my collection really quickly. It doesn't really matter which ones. And so then I'm going to close out of this box. And now I have in this panel all of the articles that I've selected. And so you're working from left to right in these columns. And if you click on any one of these articles, a new column will pop up. It will give you the name of the authors, the name of the article, an abstract. And if the PDF is available, it's going to be highlighted here. But I'm going to click out of this article. And so when you've selected your initial articles, then these are the features that are going to be unlocked. So similar work, earlier work, later work, these authors, suggested authors. So I'm just going to go through just a few of them. Similar work, kind of self-explanatory. You're going to get another column with similar work related to the first article that you collected. And then over here, here's this visualization, this network. So I'm going to just zoom in so you can see this a little bit better. The green nodes are articles that are in my collection. The blue nodes are articles that are not in my collection. So you can discover different articles. The timeline view, I'm going to actually click out of similar work, go back to earlier work so we have a better look at this. I'm going to zoom in. Again, here's that collection, and you can see how these authors are related to these different authors or articles. If we look at the timeline view, this is going to give you, this view represents the year of publication. One thing that I really like about Research Rabbit, these authors and suggested authors. So if you click on suggested authors, again, another panel with suggested authors that you can discover. And again, here is that network view, that visualization. A few more features. If I click out of those columns, there's a shareable link. So you can copy this link, you can share it with your students, share it with your co-researchers, and then you can have email updates. So when Research Rabbit has new relevant articles, it will email you. So I'm just, I know that was really quick and I apologize, but I'm going to stop that right there. And I'm going to go back to our presentation slides. to wrap up. All right. And so Allison and I have been talking about these research assistants for quite a while, since probably midsummer. And at that point, Allison said to me, Samantha, you know what's going to happen? We're going to see these publisher companies come out with features, AI features. And I said, nah, Allison, that's not going to happen. Lo and behold, like seriously, a week later, August 1st, we get an email from Elsevier noting that they are going to be incorporating AI into Scopus. So entering natural language queries to begin. Eventually, they're going to have their graphical representation to see connections between keywords. And so fortunately for all of the librarians at university libraries at Coastal Carolina, we've been able to join the beta testing. So we've been able to play around with that. And then also with JSTOR, I think it was mentioned in a previous presentation, JSTOR AI is also in beta. And I've had been fortunate to be able to test that for the past couple of weeks as well.
Yeah, and currently our library is also doing a trial of the Skype, which is like a subscription-based AI research assistant. I don't think that that one actually started as a library database, although I could be wrong. But it's been really interesting to play around with that one too. I don't know if we're going to subscribe to it or not, but we've been having fun just playing around with these to see what they could potentially do.
Great. So that was really quick. Thank you for sticking with us, joining us. So are there any questions? I will stop sharing.
You've got 1 minute. Sorry, I know it's not long.
That's okay.
There is
That's
a question.
okay.
So here it is. I know there are a lot of tools and some are paid for, but it doesn't state what you're paying for. Do you know for Elicit or other tools?
I think for Elicit, you just have to pay to use it now, but they've also incorporated a lot of features that were not free before. But I don't have any of the specifics right now. They did mention to us that they were considering library subscriptions for that, but it's not something they currently have, I don't think so.
And also, Allison, what is that token in a consensus? You eventually have to pay for that, right? To get this to synthesize.
Yeah, I think if you use too many tokens, which that part is not very transparent, so I'm not sure how. Yeah, you would have to buy more tokens to do more of the synthesis work that it does.
Okay, we are at time, and thank you both. We really appreciate it. There is one question left in the Q&A, so if y'all could try and answer that before you head out, now there's two. So if y'all could try to answer those, that would be wonderful in the Q&A section. So our next speaker is Kristian Allen from UCLA, and the title of their talk is Leveraging AI Tools for Automating Metadata Extraction. So I'm going to hand it over to Kristian.
Great. Thank you. So I should be sharing my screen now with slides.
Yes.
Excellent. So welcome, everyone. Thank you for accepting our lightning talk. We'll be giving a brief presentation on applying AI and adjacent tools with the goal of building an automated metadata extraction pipeline for digital library materials. You'll be hearing from myself and Zoe Tucker, software developers for the UCLA Library, along with Lee Fan, a data scientist at the UCLA Data Science Center, and Andy Kohler, our colleague and fellow software developer at the library, who was also instrumental in this experiment. We'd like to share our results applying a few common AI and ML tools to attempt to solve a common challenge, describing digital materials well enough to flush out a meaningful metadata record for inclusion in a catalog or digital repository. Cataloging a metadata librarian time is very valuable, so we opened an experiment with the question, could low-cost or open-source AI ML tools be used with minimal modifications to extract metadata from digital content to reduce material processing time? For this discussion, we'll be primarily focusing on digital library-centric materials, such as digitally scanned newspapers, photographs, or manuscripts. This was an exploratory experiment, and we'll need much more work to put together a practical ingest and extraction pipeline. But what we hope to do is to share what we've learned and save others time when narrowing down tool sets for working with similar types of content. So attractive attributes of a tool in this context are minimal configuration for initial use. Ideally, it would be pre-trained with similar types of data. The ability for this tool to consume a variety of file types, and the ability to output in librarian metadata standards such as Dublin Core or mods. So all-in-one LLM type tools such as ChatGPT and Bard are particularly attractive as they meet much of this criteria. The example we'll be discussing is the Campaign Literature Archive at UCLA, a collection of scanned campaign literature documents from various political races from the 1920s onward, primarily focused on California races. The current format of the material is scanned, non-text embedded, multi-page, and often multilingual PDFs. So let's take a look at a few selections. So these are the front page of several brochures from the 50s, so you can get a type of a feel for the type of material. There's a variety of candidates, propositions, and topics. And so some things I'd like to call out is the inclusion of non-standard fonts, photos and illustrations, symbols and text. There's often bleed through in the original scan, which can make it difficult. Non-horizontal text alignment, and all of these pose issues when working with automated tools, as it can be very difficult to develop a common processing scheme when many of the documents have different layouts. So this is very similar to, or we tend to think of it as similar to a magazine or a newspaper layout where there may be a caption or a photograph. So ideally, we'd like to have a tool to not only perform OCR at an acceptable level and extract the text, but also identify the coordinates of elements for use in an Alto or HOCR reader, along with the generation of a metadata record describing the overall document. So the primary tools that we'll be discussing in our experience are Tesseract for optical character recognition, Spacey primarily for named entity recognition, and ChatGPT and Bard for experimentation with all-in-one type data extraction. So since the source materials are in a multi-page non-text embedded PDF format, the OCR must be applied for a starting point to feed other tools. So, and our overall experience with Tesseract is to make sure to bake in additional time to deal with numerous edge cases that arise. I've mentioned a few here. The out-of-box configuration will definitely need tweaking when you're working with these types of materials or have some of these particular use cases. And after a text extraction is performed, you have a result that can be fed into an NLP tool such as Spacey. With Spacey, we were primarily interested in NER, the named entity recognition capabilities of Spacey, and we tested a number of canned models that were included with the stock distribution and found that the NER results would need significant processing to produce acceptable results for inclusion in a metadata record. So matching an NER hit with a name authority source, such as Library of Congress or Wikidata, would be ideal, but the model-based implementation in Spacey is still a work in progress and will most likely require your own training for acceptable matches. And there are some other alternatives we'll be discussing a little bit later on. And there are some hybrid approaches, but unfortunately, they're not all baked in, and you'll need additional tools or you'll need network access. Open Tapioca is a popular solution in this case. So an attractive solution is a tool that can perform all-in-one analysis, and Zoe Tucker will talk about her experience with OpenAI and ChatGPT.
Thanks, Kristian. So the next thing we tried was using OpenAI's large language models to generate Dublin Core records directly from the OCR text produced by Tesseract. So We found that records generated in this way are a promising starting point, but our results were highly inconsistent in quality, both between different documents and between different Dublin core fields. So in our testing, we used 2 of OpenAI's instruction following models, which are trained to carry out tasks given in text prompts. We used the 2 latest models that were available at the time, which are GPT 3.5 and DaVinci. We found a couple of techniques to get more complete and correct Dublin core records from these models. First, writing prompts that gave basic context for the materials, such as stating that the text is produced from OCR, unscanned political campaign literature, resulted in more accurate records. Using delimiters to clearly separate the task from the text was also helpful. Second, these models also have a temperature parameter that varies between 0 and 2 and represents in general the creativity of the models. Keeping this value around 1, we found gave the best results. Overall, the models performed best in fields that represent a high-level summary of the content, so title and description. And results were, as predicted, worst in fields that required any sort of external information like physical description or source. So these fields were often left blank in our results, or they contained hallucinatory data. So on the next slide, we have an example of a Dublin core record created by GPT 3.5 for the item that's excerpted on the left side of the screen there. So you can see that it correctly identified the title of this item and did find some reasonable subject keywords and a reasonably accurate description, but the record is still largely incomplete. So now I'll pass it off to Lee to talk about Google Bard.
Thanks, Zoe. So the final tool we applied to the campaign literature collection was Google Bard. Bard was able to identify content in images as well as generate metadata records. In terms of overall performance, we found that prompts requesting text were superior to results from Tesseract's OCR. However, it did present hallucinations and incorrect results when requesting links to name authorities, for example, Library of Congress or Wikidata. On the next slide, I'll discuss the prompts and results. So the most notable aspect about Google Bard was that it is able to perform all-in-one processing and that it accepts images as input, which were included in the required needs of our project. One consideration to keep in mind is that at the time, Bard accepted PNG and TIFF formats, but not PDF, which added another step to our process. Another consideration is that at the time of our project, an API for Bard was available only by waitlist, so we only performed tests using the prompt. Now an API is available for Google Pathways language model, or PaLM 2, which powers Bard, and this could be used for future exploration. As for the Bard prompt and its results, we found that slight changes in phrasing can affect Bard's ability to process the content, and consequently would affect the results. And here are a few examples of prompts that we used. One being generate a Dublin core mods and mark record from this image, and another being return the text of this document and create a Dublin core metadata record describing the document. So you can see how we can slightly modify the prompts to try to get different results. So using the prompt, Bard returned a metadata record in Dublin core, mods, and mark. And here we can see the Dublin core example. So this is the Dublin core record of that prompt result. And as you can see, it was able to provide the correct structure and overall metadata for this document. Another note to add is that at the time of this experiment, Bard would not process images, including faces of people. So when we covered the face of a candidate on this pamphlet, Bard would accept the image. So next, I'll pass it back to Kristian to discuss next steps.
So I just want to highlight a summary of our experience and the next steps and things for others to think about if you're approaching a project with similar materials. So large language models are definitely not magic, which I think many of us have experienced yet. So there are several shortcomings, and while promising that it definitely will need to be paired with additional tools in these type of scenarios to get the most effective result. Additionally, knowing the idiosyncrasies of the material that you want to work with can help save time and effort when choosing appropriate tools. If you're familiar with the edge cases with your particular project or something that makes your material unique, there are many promising projects out there that may address some of these concerns. And so an example that we found was a project called Refined, which is an NER model based tool based on entities from Wikidata. And another tool that we also explored was Reading Time Machine, which is a tool that was originally developed to extract figures and captions from digital scientific publications, but most likely could be reworked to use with magazine type content or pamphlet type content. We've also included a link to the GitHub repo, which contains the tools that we used for this project, some sample content packaged together in a Docker container to get a feel for how we collaborated at UCLA within our group for this. And I think we have a few minutes left, and I just wanted to open up the floor for questions and comments.
We've got 2 minutes. And we don't have any questions. Oh, here comes one. All right, Laura Ackerman asks, how much time per item do you think would be saved by using AI tools to generate metadata for your project? What were you aiming to have 100% AI processing or hybrid?
That's a great question. So I think in terms of time saving, I think it'd be tough to. We would hope that ideally, once you get a model trained and finely tuned for the types of materials, you could generate a passable metadata record in a few seconds, ideally, rather than having. I assume a cataloging librarian could spend a half hour or an hour, depending on the type of content per item. And yeah, you're absolutely right that it would not be efficient to shoot for 100%. It would be really difficult to reach that. I think we were just hoping for at this point something better than a coin flip that would pass the bar to be included as like a first draft in some type of repository to at least make the content discoverable rather than just sitting on a drive somewhere.
Okay, thank you so much, Kristian, Lee, and Zoe. We are at time. There is one additional question in the Q&A. So if Kristian, you wouldn't mind answering that before you go back to attendee status, I would appreciate it.
Great, thank you all.
Next, yes, thank you. Next up, we have Tim Spalding with LibraryThing. And his talk is Moles and Martians, a new LLM-based library search. Take it away, Tim.
Great. Okay. Can I be heard all right?
Yes.
We can hear you.
Excellent.
And we can see your slides.
Okay, beautiful. All right. All right, let's talk about this. I'm going to give a presentation about something called Talpa. And Talpa is a project, not a product. It'll become one eventually, but I want to talk about it intellectually. I am not an AI booster overall, but this is the least evil thing I can think of to do with AI, okay? And follow me on Threads or Twitter for more information about this. So I want to do a demo, but just for those interested, this is the tech stack and this is the data stack. Oh, I should tell you one more thing. Talpa is the Latin word for mole. 7 years of Latin got me that at least. And that's why it's called moles. All right, let's do a demonstration of what Talpa is. Talpa is currently a search system for searching libraries, public libraries, academic libraries. We hope to get it inside of your library system in some way in the future. It's good at answering questions like this. What's that book or movie with the astronaut stranded on Mars? Okay, and searching the Mid-Hudson library system, I can see that that is The Martian. They actually don't have the movie. The movie would have come second, but it puts those lower down and it grays them out because they don't have the movie in their holdings. Okay, so it's good at questions like that. Let's take Kid Has a Magic Crayon. That's Harold and the Purple Crayon. What's the story with the Six-Fingered Man? Well, it's the Princess Bride book and movie. What book begins Call Me Ishmael? Well, as you know, it's Moby Dick, right? So these are questions that a traditional library system can't answer. You might have success with Google, but not a traditional library system. YA with sparkly vampires. That might be a little further afield, but is still possible to answer. Talpa is great at spelling errors. So here I've misspelled Hemingway. What's the Hemingway bullfighting novel? Okay, you've seen these already in some library systems, but using some AI techniques, we can do really well with spelling. We can also do well with thinking errors. So what's that movie where Ben Affleck is stranded on Mars? Well, it's not Ben Affleck, it's Matt Damon, but the AI knows that Ben Affleck and Matt Damon are related in some way, and so the answer is The Martian. Now we're going to get into more subject-based searches, and I'll explain that there's something different going on for these, but first I show movies about killer asteroids. So famously, 2 came out in the same year, and these are the movies about killer asteroids, followed by some about killer meteoroids and so forth. Novels about France during World War II. So there's probably an LCSH for this, right? But you can't put it in natural language and get a list of results. You know, Suite Française, Sarah's Key, The Nightingale, right? These are a pretty good list of novels about France during World War II. Again, sub-selected just for this particular library, with the things that they don't have either removed or put down low. Here we have a series question. So what's the 7th book in the Narnia series? Bizarrely, ChatGPT by itself is not very good at series. It probably knows this one, but it's not very good by itself at it. And I'll explain what we're doing with that later. Science fiction published 1970 to 1975. ChatGPT is terrible at this, okay? So very precise bibliographic information, like the year of publication, is not something that it would know by itself. Okay. Statistics book with a yellow cover. I feel like this has long been the holy grail of both booksellers and librarians. Someone comes in and says, you know, what's that book about statistics? It's got yellow cover, right? And as we go down here, you can see lots of statistics books that have yellow covers. This one here, the library actually doesn't have a yellow cover, but one of the other popular covers is yellow. Patron might have seen that. Okay, so goes on and on. Obviously the dummies books are yellow, so forth. So that's good for questions like that, or for example, dystopia with a red cover, right? Millions of those. It can even do, what's that thriller with the Mona Lisa on the cover? You know, it's the Mona Lisa, it's a Da Vinci Code and some other ones. Amazingly, this is actually not AI, so I'm cheating a bit here. This is actually a game that members of the website LibraryThing have been playing for 13 years. And I always knew I would use this data, but 13 years later, I'm using it. And we have I think almost 4 million data points now where regular people say what's on a cover. And if they agree with other people playing the same game, then they get points. So an amazing amount of data about what people see when they look at a cover. This allows me to say, what's that mafia novel with the marionette on the cover, right? I was thinking of The Godfather, which is what came up first, but actually The Firm also has a marionette on it, and there's some other ones too. I can't remember. I don't know why it's doing it that one, but anyway, it's not foolproof. And then finally, we get to sort of All Together, which is novels about France during World War II with children on the cover, right? How would you answer this question otherwise, unless she's very, very specifically new, right? And there's several of them, right? And this allows you to combine, you know, a color or the objects on a book together with what's going on with it. All right, so now let's talk about how this is all working. It's lovely. It only took 5 minutes, so I have a little bit of time here. So how does this work? So to backtrack, AI is good at knowing things in some sense. There's a degree of intelligence that emerges from this overhyped autocomplete, and it has a pretty good understanding of natural language. What it's bad at is, first of all, what's been called hallucinations. Hallucinations are almost a misleading way of thinking about it. The key thing to think is that an AI, a large language model in any case, is not a storehouse of facts. It doesn't have facts that it draws on. It is language all the way down. It is rhetoric all the way down. So it's not actually hallucinating or not hallucinating. It's always hallucinating. It's always auto-completing. Obviously, it's been mentioned that librarians are already receiving requests for books that ChatGPT has dreamed up because it doesn't know what books exist and what books don't. So, solution number one, the first thing that underlies what Talpa is doing, is interpreting and constraining AI with verified authoritative data. That means when ChatGPT comes up with a book that doesn't exist for a query, we throw it out. Right? We interpret what ChatGPT is doing, turn it into a book, know that the book exists. We also know that the book exists in the local library because that can be important. And then we're using all this authoritative data, Bowker, Syndetics, LibraryThing, library holdings, large amounts of marked data in order to constrain what's being produced. Okay, no words come through ChatGPT into Talpa. There's no leakage of words. So in some sense, it's just books. Solution two, which I think is much more interesting, is that it is using the power of natural language to do some things that ChatGPT can't do. So first of all, you take a question like literary fiction about World War II in France. It can break that apart into different pieces: literary fiction, World War II, France. And that data can then be fed into traditional library systems, or for example, tags, which LibraryThing has 180 odd million of, to get a result. The intersection of these three genres, concepts, tags, LCSHs. Similarly, when I say something like, what's the Magic Treehouse series book after Tonight on the Titanic? Sort of question that really is hard for ChatGPT to handle. It can look through the list of, I don't know, 40 Magic Treehouse books. If you're a parent, you probably have read them all, and it can cross-check that against an authoritative list, which we have. Okay, it's also possible using these techniques to be current, whereas large language models at the moment are not kept current. Some moves in those directions, but as soon as the authoritative bibliographic data exists, then the natural language parsing together with the data can produce the right results. All right, so is this a model for the future? I think so. It is not evil. It is not high stakes. It's not from a giant vendor. I am continually amazed at the rollout of AI into high stakes situations. A 1-ton car going across the road. People invent AI and then they're like, let's use it for to talk with suicidal people. No, do something simple. Do something low stakes like this. Right? This isn't reinventing the wheel either. It's library search. Okay, something that your library already does. Most OPACs, as you probably are aware, are pretty terrible. So if we can make OPACs, 2% better, that seems to be like a win. Okay. I am afraid of a lot of the uses that this technology is going to be put into libraries. This feels like one that I don't need to be afraid of. But more generally, the technique going on here is merging the world of AI with the high quality authoritative data which libraries are known for, which libraries create, which libraries are in charge of. And I think the merging of these new technologies with high quality data is where this can go. That's it. I have 5 minutes left, I think, or 4 anyway. So please, I'd love to answer your questions.
You have 3 minutes, and there is one
3
question in the Q&A
Mhm.
from Gary Atwood. Let's say you run a search and get a lot of results. Will Talpa let you run a second search that's limited to the first result set to narrow it down?
Not right now, although that's a decent idea. And right now it is completely stateless. So no, each search is a different thing. But that is a good idea. I want to keep things simple at the moment and really improve quality. One of the things that let me see if I can get this. Sorry, that I can't because it's covering my URL bar. But anyway, we have some 600 queries that we run this against. And constantly monitor the quality of the results. And we're always looking for new ones. And so my focus is on making this better and better. But yeah, in the future, I think you'll see that. You'll see, manual ticks here and there for filtering by this and filtering by that. Whether we end up doing it or whether other vendors end up doing it or we all do it together, I think you'll see things like this appearing in traditional library search. My hope is that they are simple to use, ethically made, and don't invent things, and that ought to be the minimum. Anything else?
Yes, you have a couple others. Hannah wants to know, can you explain a bit more how you run the generated queries against your data?
The generated queries. Well, so I mean, some of them are simply going to ChatGPT. Well, I should say everything is going to everything. So we always send things to ChatGPT and Anthropic, another API. But we're also just simply asking ChatGPT questions like break this into its component pieces. And then, we can use those component pieces to run them against tags, series, date ranges, where the author's born, etc. It's really using the power of AI to process the language naturally. And then at the end, you put all the data together with all kinds of other searches that you do and try to come up with a unified result.
All right, I think we might have time for one more. Brandy wants to know, how does Talpa handle slang?
Oh, good question. I think pretty well, simply because of that. So, oh gosh, I don't know. I have a good question about that. It actually handles other languages quite well too. That's where sometimes our data might not be perfect, but you can ask it questions in French and it'll come up with answers quite well too. But yeah, I think it's pretty good. I mean, YA with sparkly vampires shows it has some sense of what's going on. I don't know. Try it out. You can go to talpa.ai and try it out. We just pushed a new version. I can already see some problems with it. We're developing it over time, but try it out and tell me what you think on Threads or Twitter. Thank you.
Thank you, Tim. There's one more question, if you wouldn't mind answering it.
Please,
I mean, not verbally, but I'm going to let the next speaker go.
Okay.
If you could stick around and answer it in the Q&A, that would be wonderful. So thank you very much. We appreciate it. All right, our next speaker is Brendan Quinn from Northwestern University, and the title of the presentation is Starting the Conversation, Enriching Collection Access and Use with Generative AI at Northwestern University Libraries. Take it away, Brendan.
Thank you so much, Heather.
Sure.
I'll share my screen and just let me know if y'all can't see it.
Yes.
So maybe you just got a sneak preview of the demo part of my talk.
Yes.
That's okay, I'll let it slide. All right, so thank you for having me today. I'm just going to hide my floating meeting controls here. Okay, so yes, thank you for that introduction. Starting the conversation, enriching collection access and use of generative AI at Northwestern University Libraries. I am Brendan Quinn, a senior developer at Northwestern University Libraries. I've been there for about 13 or 14 years now, and I work on our repository and digital curation team. And so I'll just read really quickly. Our mission is that we create, acquire, describe, and archive digital objects for long-term preservation, and develops as well as deploys software to support the discovery, access, and use of digital resources by members of the Northwestern University, scholarly communities, and the public. So we host our digital collections at Northwestern. at the library. So here's our team. I work with a team of really excellent developers and project managers, Scrum leads, etc. So Adam, myself, Carolyn, David, Karen, Matt, Michael, and Veronica, we've all worked together on this prototype. So anytime I say we during my quick talk here, that's who I'm referring to. So really quickly, just a quick agenda for the lightning talk. What are our project goals? What I'm going to talk about today. The high-level overview of the project, aligning with our values, building the prototype, a quick demo, and then a little recap about how things are going. So firstly, our project goals. We want to provide a way for users to ask questions and receive answers from a large language model grounded in our digital collections data. So a state-of-the-art language model. In this case, I'll be talking about ChatGPT's OpenAI 4, which we have a subscription to via Microsoft Azure AI. So for our project, we sort of had two options and two paths to go down. And some high-level requirements were that we want to have our users interact with our digital collections in a new way, but we want to do the same thing that we've always done, which is connect people to research and material that will help them, digitize material that will help them with their research or study or entertainment or what have you. So that's one of our requirements, is to still be useful and provide good links to good resources for searches. But we're doing it in a new way, and that way involves a generative AI tool and a vector database. So, and I'll talk a little bit about like what our options were. We could have fine-tuned a model that was sort of off the shelf, but that would require experience that our team doesn't have, like building training data sets and evaluating model performance and things like that. So we did not choose that route. We chose instead the second route, which I'm calling instruct here. And so that is the choice we made, which where you, it's also known as a strategy called retrieval augmented generation. And in this strategy, we take a user's question and we pass it to a vector database, which returns a set of documents from our digital collections that match the user's question based on their cosine similarity. Which I won't go into detail now, but feel free to reach out if you have questions and want to talk after. A large language model, that's OpenAI's GPT-4, and then an application to make requests and handle processing all the information. So that's our job here in the scenario, is build out that prototype, that last layer. So for the overview, we've got an API layer, and that's what does the pre and post processing of events and handles authorization and authentication, things like that. A front-end application, which is what our users interact with, that asks the questions to the API and gets the responses back. And then the vector database, which we have hosted in Amazon Web Services. And vector databases are very similar to a traditional database, but instead of storing documents, you store vectors, which are lists of numbers that represent our digital collections materials. So how do we align with our values? That's one thing that we've been keeping in mind for the whole project. So we want to build a tool that is useful. We have a sort of a team discussion about just making things that are useful to people all the time. So we want to build a tool that somebody can get something, a benefit out of. We want to be transparent. So what does that mean? We want to show and highlight areas where generative AI is at play, where vector database queries are happening, and we want to make it clear to users what things are being generated and what is not. And then the last one is working in public. So everything that I'm going to show here is our code is hosted on GitHub and public repositories that are available for anyone to see. So here's our prototype. So we have a couple of ideas here. We want to make speedy responses grounded in our data because we want to solve the hallucination problem that LLMs have currently. So by inserting our data into our request, we're grounding the LLM and letting it make an inference or answer a question based on good data that we control and manage. We want a responsive interface for providing a way for users to ask questions. So, and that's kind of the transparency part that I was talking about. We want it to be clear when it's a generative AI response, when it's their own question, those kind of things. And then we also want a quick feedback loop for easy iteration, deploying, and testing. So those are the prototype pieces, and I'll just go into the demo. So wish me luck. So this is what, it'll take a second to load here. I'm using this browser called Min because it doesn't have like extra Chrome and like bookmarks and all that stuff. So it's a little easier to use for demo purposes, but it's a little slow. Okay, so here's the prototype. You can see here it's a Next.js application. It's running in AWS in the cloud. The API is also running in AWS cloud with Lambdas that scale behind it. So like our whole infrastructure is in the cloud and scalable. This is a Next.js and React application. So everything is broken down into components with type definitions and really nice separation between functionality. So we have here a really simple interface, which is just a search box that we're trying to highlight just the conversation. Just ask a question and see what kind of answer you could get. So I'll start by asking a question, and then I'll talk about what is happening. So what happened at the bursar's office at Northwestern in the 60s? So this is a really kind of conversational type of question, and I hope this works, which I think it will. So right now, this the blinking loading screen you see here is a vector search that is being performed. And you can see the tokens streaming in from the generative AI below. So what do we see here in this response? So this is my question. These are the documents that were returned from the vector database search. These percentages here indicate the similarity between the question and the document. So you can see it's sorted by similarity, so it goes down as we turn here. And then here you can see the large language model's response, which it says they don't provide a detailed account, but they describe the bursar's office takeover in May of 1968 was a student protest. And this, I would say this is a really accurate and really great answer for this question. And then this little about this answer thing says, it's a little warning and a disclaimer that we're using an LLM here, the results may be inaccurate or even harmful depending on what you ask and what the LLM gives you. So just a disclaimer and a warning that some extra caution. And then I just kind of wanted to show a couple of queries and document results. So I'll start at the bottom here. So this is kind of like just a basic question, like where is Northwestern University? And you can see based on the documents, it says it's located in Evanston, Illinois, which is kind of interesting, but not that exciting. But here's a more like sort of meaty question. Can you tell me about the Berkeley Folk Music Festival, which we have a large collection at Northwestern about the Berkeley Folk Music Festival. And so who created it, any major performers? And so you can see here, the documents are all linked back to our digital collections. And then the description really answers like each piece of my question here. So it's like it took place in Berkeley. The director was Barry Olivier, who I've met and this is correct. And then and then here's a list of performers that it extracted out of the metadata from the documents, just answering my question. And then I'm a big fan of John Fahey's work. So I asked, I noticed John Fahey in the list of performers, and I said, can you tell me which songs he played or anything? And then so it says it doesn't say which songs he played, but it does say he played at, the festival in 1968. So that's just a way to kind of continue a conversation. We don't have it like building out conversations in each little section, but you can, ask follow-up questions, just by asking again up here at the top. There's a couple of silly things, but I think they're really interesting here. Like, are there works related to space? So this is kind of like a little expression of like what I put in sort of has a major impact on what comes out. So I said, answer as if you were a Star Trek captain entering a log, please. And you can see captain's log, start date 2021. And that's actually the training date cutoff, which is a really interesting little point there about that 2021. And then, so here's some other interesting things. So I'm saying, please answer by creating MLA citations out of the metadata. So I ask a question, and then you can see here a numbered list of MLA citations. Here's kind of a fun one. What kind of food could I eat if I traveled by luxury plane or train in the 40s or 50s? So this is a really informal kind of way of asking this question. And the results are just so excellent here, where it shows our menu collection with these really interesting menus, and then it extracts all these food ideas from this, and really goes into a lot of detail. And then, so let's say I'm interested in this menu because of this cute bear here. I can just click on this, and I can get right to our digital collections site and see our bear. Oh, this one might be oh no, it's public. So this is a link back to our digital collections site with all the metadata and everything that a user would want for that, to get more information about that particular thing. So I think with that, I think that's all I had. Let me go back really quick. We have a couple for the demo. We have just a few points to say about like what's coming up and how it's gone. It's going really well. We've had some issues with managing token counts and running into token limits. So we've been writing some tools to help deal with that. And could expose sort of the statistics about tokens. And then we've had some like little hiccups about balancing, like what we retrieve from the documents, what we send to the LLM, and how we prompt it. So those are kind of things we're still working on. And then what's next is user studies with our user experience librarian. And so we're going to get people using the prototype and getting some real feedback. So that's all I got.
Thank you very much, Brendan. We have a couple minutes left before the next session, and there are several questions in the Q&A. I'm going to ask the first one, but if you could answer the others after your presentation concludes, that would be wonderful.
Yeah, I'd be happy to.
So the first one is from Laura Hall, and she says, "Hi, Brendan. I'm curious the percentage of materials digitized by Northwestern. Is this tool also able to look at EADs for materials related but not digitized?"
That is a great question. Thank you for answering that. I just totally forgot to mention that in one of my slides. The total number of documents is it's 83,000 works, and it's all extracted from our digital collections site. It represents all of the metadata for public and authenticated items in our digital collections. So that's things that are behind a net ID for Northwestern students and faculty and staff to be able to see the items in our digital collections, like the images and videos themselves. But the metadata is public for those things. So it's all public metadata that's hosted on GitHub that's like in several formats. So we process that public metadata to ingest it into the vector database. And then so that's the data that we're using. And you could transform your data in any way that you want. Like we're using, like we defined our schema with title, subject, however, but the customization there is kind of up to you, however you want to do it.
Okay, thank you so much, Brendan.
Sure.
We appreciate it. And if you would stick around and answer those 3 questions in the Q&A, we would appreciate it.
Yeah, thank you so much.
Yes. So next up, we have 2 presenters from the Georgia Tech Library, Raven Davis and Kristen Brown. And the title of their talk is Generative AI, Intellectual Property and Marginalized Groups, How Libraries Can Minimize Harm to Marginalized Populations. All right, so take it away.
Okay, hold on one second.
We can see your slides. So perfect.
My name is Raven Davis. I'm a research scientist here at Georgia Tech Library, and I'm joined by my colleague, Kristen Brown. We're going to be presenting on generative AI and how to minimize harm for marginalized communities. So in our presentation, we're going to cover the background of generative AI, the historic exploitation of marginalized communities, the impact of technological innovation, the role of the academic library, and best practices we can implement to minimize harm. So firstly, what is generative AI? Generative AI is a type of artificial intelligence that has the ability to create new content, such as text, images, music, art, etc., based on user prompts or input. So generative AI relies on training data, which is data used to build a machine learning model in order to produce this content. Using training data, usually millions of contributions acquired through various means, such as web scraping, these generative AI applications apply various machine learning algorithms to identify patterns, establish rules, and generate new content. Thus, by design, the tools require access to people's intellectual property in order to create meaningful or useful results. The question then becomes, how can we serve those who wish to use this tool for innovation while also protecting the intellectual property of those whose data is used to create the model? And even more specifically, the intellectual property of people who have suffered most historically from lack of protection. AI tools and applications have had a huge boom over the past couple of years, with technology in this sphere advancing rapidly over a very short period of time. ChatGPT, which was released in November 2022 by OpenAI, is seemingly credited with jumpstarting this reinterest in AI development. ChatGPT is a large language model, or LLM, and this AI tool has the capability to recognize user input and respond to that input via text, similar to a chatbot. Similar to other current AI tools, however, in order to enable these interactions, ChatGPT has been trained on billions of tokens of data. Aside from ChatGPT, there are many other applications that have emerged over the past year that function in the same way. AI tools like Midjourney, Stable Diffusion, and DALL-E generate images based on users' text input. Synthesia, an AI voice generator, takes user-provided text and generates natural-sounding narration using their database of more than 120 male and female voices with different accents and languages. Soundful allows users to create AI-generated music, and there are even AI tools like Jenny AI, which can write essays and research papers. So the usefulness of these tools depends heavily on the data being used, however, and that data is not always acquired with the consent of writers, researchers, creators, and artists. So how are universities handling the emergence of these tools? Many universities have begun incorporating and embracing the use of generative AI in their policies. They're encouraging students to learn how to use generative AI tools in responsible ways. Failure to cite or unauthorized use of generative AI tools is widely considered plagiarism. And evaluating the quality of the training data used by the tool and properly citing the authors or creators used in the training data is a responsibility being left to students. So, taking the time to evaluate where the data from these tools is coming from and putting forth effort to acknowledge and properly attribute these training data to the authors and creators used to generate the content being used is a part of students' responsibility under the Academic Honor Code, as well as an ethical and responsible user of AI. So now my colleague Kristen's going to take over.
Thank you, Raven. And so I'm going to bring in the portion of marginalized communities. And so to begin this conversation, I want to highlight a quote from an article published by the Copyright Alliance, basically reporting on copyright and social justice, which was an event held at the Copyright Office in 2020. Historically, there has been a social injustice with respect to accessing and reaping the benefits of the copyright system. For example, many creators, and particularly racial and ethnic minorities, have disproportionately suffered the negative consequences of pirating creative works and have not been able to enjoy the fruits of their labor. So research suggests that improper exploitation often stems from one's lack of ownership and control over their creative works. For example, KJ Green, who is a scholar in the study of IP and race, highlights how copyright protection is traditionally owner-centered as opposed to creator-centered. And this means that copyright owners retain a greater portion of their financial control. So inequitable deals and divisive industry practices often stripped marginalized artists of control over their work. This led to the wrongful exploitation of their work for the financial benefit of other stakeholders. So the wrongful exploitation of artistic works has increased with the explosion of technologies. For example, the founder and director of the Institute of Intellectual Property and Social Justice at Howard notes how since the later decades in the 20th century, the advent of digital information and technology has prevented novel socio-legal challenges to the copyright law. And this conflict between technological progress and copyright law is widely recognized and has been traced from the internet era to the rise of social media. So before generative AI, there was social media and machine learning. With that being said, I would like to draw a parallel to social media to further illustrate this issue. So social media platforms like Instagram and TikTok initially struggled to sufficiently regulate mass copyright violations, facilitated through the ease in which users can upload copyrightable material and the momentum in which videos and material can go viral. Additionally, there are instances of intellectual and cultural appropriation impacting marginalized creators on these platforms. This issue is partially a result of the attribution challenges stemming from the algorithm and feed design of social media platforms as powered through machine learning. So in essence, we must learn from our past in order to inform our future as we tackle this issue. The potential challenge of wrongful exploitation stems from the large use of quantities of training data to teach AI models and a lack of understanding about attribution issues. For example, a fundamental lack of understanding of model attribution will result in cultural appropriation if the training data comes from or contains content from marginalized communities. And while this issue is still new and emerging, there are potential examples of cultural appropriation within the context of generative AI. In the audio context, research suggests that generative AI models make it easier to use content from marginalized cultures without any accompanying investment in or engagement around the community, even if the creators or users of that model are unaware of the use of that content. Other potential examples exist within the current litigation, which is still ongoing, however, but The Atlantic did publish an article that talked about the use of alleged 191,000 books, which particularly impacted marginalized creators as well. So with that being said, I will now give it back to Raven so she can discuss the role of the academic library in confronting this issue.
So the role of the academic library. It is especially important that places of research and innovation like the library be on the front lines, be proactive, and embrace this technology in order to best provide guidance and best practices to researchers. By embracing this technology, we can instate policies and provide guidance that keeps in mind the protections and best interest of these vulnerable populations that we seek to protect. So the Association of College and Research Libraries Framework for Information Literacy for Higher Education outlines 6 frames for librarians to incorporate into their instruction of information literacy in collaboration with teaching faculty and for the evolving needs of students, especially with the changing technological landscape. This framework and the guidance it provides for information literacy instruction can and should be expanded to explicitly include how learners developing their information literacy must also understand the ways that underrepresented or systemically marginalized people may not receive adequate credit for their intellectual property used in AI tools or other technologies due to the tool's design, and emphasize the responsibility of users to respect the intellectual property included in those tools as well. The International Federation of Library Associations and Institutions also released a statement on libraries and artificial intelligence. The IFLA statement includes information on incorporating AI literacy into information literacy instruction, like the ACRL's guidance, and emphasizes using AI literacy to promote ethical AI practices and ensuring that users of AI tools do not reinforce biases. Although most research in this space regarding bias currently focuses on the outputs of these AI systems, expanding our understanding of how information literacy and ethical AI also pertains to the intellectual property used by these systems will ensure that patrons and libraries are informed about the potential harms to marginalized communities and adopt policies and technologies that mitigate that harm. So moving forward and taking into consideration these frameworks and recommendations from various library organizations, we have created a short list of best practices as a starting point for libraries wishing to minimize harm to these marginalized communities as they adopt their own generative AI policies. So firstly, providing guidance on copyright policies regarding generative AI. Being aware of relevant copyright policies regarding generative AI can ensure that libraries and patrons are using this technology ethically and legally. The U.S. Copyright Office has an AI information page, and universities are currently adopting their own copyright and fair use policies in regards to generative AI, as well as incorporating those into their academic honor codes. Publishers are also developing policies on the use of AI in scholarly publications. We can also encourage the evaluation of source data. So proactively evaluating the sources of the outputs of these tools can ensure that users are respecting the intellectual property of contributors to these tools. Have I Been Trained is a website, a reverse image search website that searches specifically within AI training data sets to see where those images are coming from so that they can be cited properly. Using these tools will go a long way in minimizing harm. We can also communicate the best uses for AI tools during research. For example, ChatGPT is recommended as an efficient way to brainstorm topics and provide useful keywords for further research. We can also provide examples and guidance on the best ways to use these tools in ethical and creative ways that focus on starting your research or creative process instead of using the tool to generate the art or content. We can also build AI literacy from a human rights perspective into information literacy instruction explicitly. We can focus on incorporating AI literacy in instruction that will ensure students and researchers are aware of how intellectual property is incorporated into these models, and ensure that researchers respect this intellectual property and prioritize crediting these communities with their contributions. And lastly, we can embrace AI technology proactively. By ensuring we are working with and learning these tools on the front end, we can better educate students and empower them to evaluate these tools critically with the goal of ensuring that research is not negatively impacting or exploiting the works of vulnerable populations. We can also intentionally incorporate ethical generative AI tools for research that prioritize the protection of intellectual property and are, as a result, less harmful to these communities. And in closing, my colleague Kristen is going to take over.
Thank you, Raven. And so in conclusion, we are a key piece of the generative AI and research landscape. And as we rush to develop instruction and policies regarding these new technologies, we must always keep in mind the voices of those most vulnerable populations and work not to repeat the mistakes of our past. Intentionally prioritizing the protection of these communities and their intellectual property is an important and impactful first step. Thank you.
Thank you very much, Raven and Kristen. That was wonderful. We are at time, but you do have a couple questions in the Q&A. So if y'all wouldn't mind answering those after we end the presentation, and they'll be either you can type the now you've got 3 in there. So more might come in. But anyway, so you just go in and choose type answer.
Okay, great.
So we are going to take a short break. And when we come back, we're going to have the closing keynote with Marshall Breeding. So we will be back at 3:45 Eastern. So that is basically 11 minutes. Is that right? Yes.
We
So
also
we'll
have
see you
a
back there
poll
in
on the chat. If they can do the poll on the chat, it'll be great.
Yep, Anu just posted the link to the poll. So if y'all could take care of that, that would be wonderful.